The History of Quantum Mechanics, Part 3, Werner Hisenberg.
Werner Hisenberg, a brief biography and history. Early life and education. Werner Karl Hisenberg was born on December 5, 1901 in Würzburg, Germany. Hisenberg came from an academic family. His father, August Hisenberg, was a professor of Byzantine history. Hisenberg attended the Maximilian Gymnasium in Munich and later studied physics at the University of Munich under Arnold Sommerfeld and Max Born. Academic career and key contributions. Doctorate work, early work. Hisenberg received his doctorate in 1923 with a dissertation on hydrodynamics. He then worked with prominent physicists such as Niels Bohr in Copenhagen, which significantly influenced his thinking. Development of quantum mechanics. Matrix mechanics, 1925. Formulation. In 1925, Hisenberg developed matrix mechanics, the first complete formulation of quantum mechanics. He introduced the idea that observable quantities in quantum mechanics, such as position and momentum, could be represented by matrices. Collaboration. He worked closely with Max Born and Pascal Jordan to develop the theory further, resulting in the formal mathematical framework of quantum mechanics. Uncertainty principle, 1927. Heisenberg formulated the uncertainty principle, which states that it is impossible to simultaneously know both the exact position and momentum of a particle. This challenged the classical notion of determinism and introduced fundamental limits to measurement in quantum mechanics. Impact. The uncertainty principle is a cornerstone of quantum mechanics and has profound implications for our understanding of the nature of reality. Key principles and interpretations. Copenhagen interpretation. Collaboration with Niels Bohr. Heisenberg was a leading proponent of the Copenhagen interpretation of quantum mechanics, which he developed in collaboration with Niels Bohr. This interpretation posits that a quantum system exists in a state of superposition until it is observed, at which point it collapses into a definite state. Philosophical implications. The Copenhagen interpretation emphasizes the role of the observer in the measurement process and has been a subject of philosophical debate since its inception. Later life and work. Nobel Prize, 1932. Heisenberg was awarded the Nobel Prize for Physics in 1932 for the creation of quantum mechanics, including the discovery of the all-important uncertainty principle. Nuclear research. During World War II, Heisenberg was a key figure in the German nuclear weapons project. His role in the project and his intentions have been the subject of much historical debate and scrutiny. After the war, Heisenberg was detained by Allied forces for a brief period. Upon his release, he played a significant role in rebuilding scientific research in Germany. He became the director of the Max Planck Institute for Physics and continued his work in theoretical physics. Personal life and legacy. Heisenberg married Elizabeth Schumacher in 1937 and they had 7 children. He was known for his dedication to his family and his love of music, particularly playing the piano. Character and influence. Heisenberg was known for his intellectual rigor, philosophical depth, and commitment to scientific inquiry. His work laid the foundation for much of modern physics, and he remained an influential figure in the scientific community throughout his life. Death. Werner Heisenberg died on February 1st, 1976 in Munich, Germany. Legacy. Quantum mechanics. Heisenberg's contribution to quantum mechanics, particularly the development of matrix mechanics and the uncertainty principle, are fundamental to the field. His work has had a lasting impact on the way physicists understand the microscopic world. The Copenhagen interpretation remains one of the most widely taught and discussed interpretations of quantum mechanics, influencing both scientific and philosophical discussion. Scientific leadership. Heisenberg's efforts to rebuild German science after World War II and his leadership at the Max Planck Institute helped shape the direction of post-war scientific research in Europe. Philosophical contributions. Heisenberg's writings on the philosophical implications of quantum mechanics continue to be influential. His reflections on the nature of reality, determinism, and the limits of human knowledge are still relevant to discussions in both science and philosophy. Werner Heisenberg's pioneering work in quantum mechanics and his profound contributions to theoretical physics have secured his place as one of the most significant physicists of the 20th century.